So, good morning and welcome everyone to MuleSoft Mysore Meetup group. So, today we have the topic um, application design thinking with respect to integration. So, this is the part two. We have already covered part one in the previous meetup. Okay, can you forward to the next slide? Okay, next. So, before we continue with our presentation, let me read out some safe harbor statements. So, both the speaker and the host are organizing this meetup in individual capacity. Okay, we are not representing our companies, and it is strictly for learning purpose. Okay, next slide. Yeah, so we are recording this, and if you want to revisit and recheck the content, okay, so you can go to our YouTube page or the events page. There you will find the recording of this meetup. Okay. Questions you can feel free to ask anytime. Okay, in the chat, or you can enable your mic. Next slide. Yeah, so we have two organizers for this meetup. Okay, Giri is not available, so we are both MuleSoft ambassadors, and I am working as a professional integration developer in Millennium. So that's all about us, and over to you, Robin.
Thanks, Shivam. So I'm Robin Sinha. I'm certified MuleSoft integration architect. I'm also a MuleSoft mentor. So under multi-cloud initiative, I'm also AWS cloud practitioners certified and also certified GCP associate cloud engineer. Right now, I'm working as specialist 2 in Hasdin by Deloitte. I have around 3+ years of experience in integration. So today our agenda is to discuss about what are architectural designs. Is it the backend or the backbone of any technology? Why are why a good design architecture is important for any application? How integration architecture impacts the design of an application, and we will have a small demo and then after that a Q&A session. So this all topics will be covering under design thinking. So this is the part two of design thinking. So let me take you this for the let's take a recap at what we discussed in the part one. So part one, we discussed about design thinking definition. What is the importance of design thinking? What are the goals, process, stages of design thinking? We discussed what is the definition of a good design. We discussed what are the different models which are given for the design, which are the prescribed models for design thinking. And later, at the last stage, we discussed some real life business use cases, how their design visibility and design vision changed the way the company had growth and disrupted the market. So we discussed some of the examples like Netflix, Apple, and Tesla. So the recording of this session is also available at the YouTube channel of Mysore Meetups. If you want to have a closer look on these topics, you can go. And after this meetup also, you can go and check that too. So that is more about the design thinking process. Now this is more about the integration architecture and how we think and design that. So let's start. So this is design thinking, but part two. So before we start, so anyone of you who have any prior experience or have knowledge that what are architectural designs? Anyone? I'm audible, right?
Yes, you are. Yes, you are.
Okay. So so let's discuss what are architectural designs. So basically, architectural designs refers to the process of creating a blueprint or a plan for structure, organization, behavior of a software system or application. So basically, in terms of any project also, any architectural design, so it's a very initial phase. So when you start that, you plan for the structure, how of the organization of the systems, how the behavior of the software will be, and then you later lay that path. So it also encompasses different aspects. Basically, it like including the selection of appropriate technology. So when you start the architectural design, you decide what technologies you're going to use, which is tech stack, what what you're gonna work on. So there are different tech stacks available. Like for example, front end you can go for Angular, you can go for any different React. So any technology you're choosing, right? So then you'll have to first design and you have to think what is more beneficial for you, what is more cost efficient to you, and how your teammates are well trained on. So basically, if you have a React team, it would be better, or it will be suggested that you should go with a React based architecture, not Angular based, when your team is already has an expertise on React. So the company will pitch and try to give go and take and ask the client to go on React. If the client is resistant to go on Angular, or they have earlier, like even they have the past experience with bad experience with React, and they have already inbuilt architecture for with like basically for different products on Angular, then they will ask you. Then you will have to go again with the training and development, and again you have to train your resources again on the Angular part, and then you can start the project. So again, appropriate technology. Again, as an architect, so this architectural designs are generally made by solution architect. So you have to design your system boundaries. So there can be many systems interacting with each other, but there are contracts, and there are, you as a solution architect has to need to set what are the boundaries they can interact with each other, what the data can be shared, and what cannot be. So again, this is communication protocols you will have to share. You have to set that how they will interact and at what extent they can share the data. Again, data storage mechanism you have to build and select how your data will be stored in which form and where. All the DB properties, for example, atomic properties of DB, you have to follow, and you'll have to set how those, how you have to ensure it that it is getting followed. And again, when you design all these things, when you design in the diagram, right, you make all these things visible, clear and loud, and then you also depict what will be the overall system behavior of your architecture design. So again, it is vastly involves making decisions about the system structure. For example, first, the division of responsibilities among different components, the flow of data, the control, and the mechanism of system extensibility and scalability. So as you see in the diagram, in this diagram, if you see, there are multiple services, multiple systems, and multiple teams involved in the same application. So here they are working isolated in their own domain, but again they are working together to make the application work. So basically there are different teams, backend teams, front end teams, SEO engine teams. Every person, they have their own work. They are working in an isolated environment, but they're working together to run an application. So as a solution architect of the project, you have to think like that, and you have to make the design so that your if so for example, if you are solution architect of the project, if you are a MuleSoft architect, you have to decide how your MuleSoft APIs will interact with different systems, and you have to set your boundaries. So again, it can be hierarchical as well. So there can be a parent, and there can be child systems. So again, you have to decide what child systems have the boundaries and what parent system have the boundaries. So all those things you have to decide while before making that architecture diagram or architecture design. So before we go deep into architecture designs, let's first, as we are MuleSoft developers, let's first get a role and get to know about what is backend first, and then we'll come back to this architecture designs and we'll discuss more on it. So coming to backend. So any one of you, if first word comes in your mind, strikes your mind, what you think about what is a backend? Anyone? Okay. So basically, backend is what you don't see, right? So for example, what is the front end and what is the back end? The difference between front end and back end is what you can see, interact, experience is front end. For example, the it's any website, any, like for example Instagram, right? You have like feature, you can interact, you can chat with each other. And but what is the backend is, you won't be, as a customer you won't be able to see, as a user you won't be able to see. But it's not a, it's not a visual aspect of anything, any application, but it's the depth, like it's the structure, the backend structure, where all things happen, basically the logic, the structure. For example, in Instagram, if you message someone, you just see the message browser, the name of the person, you say hi, right? After that, in the back end, what happens, what you don't see is a much larger process, where a call happens, where the encryption happens, again in this target, the description decryption happens, the data is, a pipeline is created between you two. You can be in a different server, he can be in a different region and server, he, because he, you know now we can interact with people who sitting in US and people sitting in India at the same time, right? So all these things, the logic, everything happens in the back end itself. So so there's a question to us: can we say that, is it the back end or the backbone of any application? Because backbone is what the spinal cord is, and what you see, for example, what you see from your eyes is just the data. You get the data as a front end. It is inverted, right? It is, what we see is actually the eyes are getting inverted data, right? And then it is translated to the brain is like a CPU server, and then the basically the spinal cord, right? It changes everything. It sends the data to your hands, your legs, your every muscle. So if you have a burning sensation, so again your skin is a front end. It gives the signal to your spinal cord. Spinal cord again gives as a backbone, or the back end gives the signal back to your hand or muscles to keep take your hand away from the fire. And it's also inform at the same time your brain that your hand is burning. But even if you don't know, if you don't see that your hand is burning, automatically it's like a motor reaction from the spinal cord itself, your hand goes back. So similarly our backend works. So it's the same design, how God designed humans, we design applications, so that in everything our backend should be there. It should be threat protected, it should be fault tolerant, so that anything happens it should take decisions on its own. And also afterwards, it's a backend responsibility to send the appropriate response to front end, so that they can also display the data to the users. For example, something happens, if, and it depends upon the front end how they want to display. So if we will send the front end that, okay, this process failed, we're not able to fetch. Now it depends upon the front end if they want to show the same message or they want to show something else. For example, if the connection failed in the backend, Instagram won't tell you that a connection or process failed in the backend. Backend would tell the front end. But what Instagram as application, the front end will do, they will so they will they will say no internet connection. But maybe it is a fault of somewhere else, and your internet is in, even if it is working, may it can choose to not respond or not, just to show that the application is not laggy or something. It will just take some time, and after that it in the backend it will continue to try to fetch the data, and as soon the data comes it will give you, to make your user experience more better. So again, yes, the answer is yes, backend is the backend. So now, what are the responsibilities of the backend? If you come to that point, how we can say that it's a backbone, right? In the terms of architecture, now we discussed in terms of any application. Now, in the terms of architecture, let's discuss what are the points, how we can say backend or architecture diagram design as a backend is so important. So it 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 creates a foundation. When you design a backend, through architecture design or architecture design thinking, first you need to set the foundation. It provides the foundational structure for any technology. It also establishes the fundamental principles, patterns, components that make up the system. Now, without a solid architectural diagram, the technology may lack stability, reliability, and scalability. Again, again talking about scalability, you know, it also serves as a basis of scalability. It enables the technology to handle increased workloads, user demands, data volumes, and a scalable architecture also ensures the system can grow and expand without sacrificing performance and stability. So, in anything comes, a new thing comes to a new challenge comes to, or for example a new integration or new system comes, then you should make an architecture diagram or design in such a way that it should accept that again, and try to fit it in your existing design and not change the design itself. So there is some changes that can be done as a enhancements, so there should be always a room for enhancements, but not the basics of design. So for example, in real life scenarios, Flipkart can add some of the aspects of messaging. If you have a family in Flipkart, they can add that, but they won't change the whole backend design, which as which is their definition as a marketplace. They won't change themselves as a chat or a chatting platform, but because the measure of the part is there, it's a marketplace, and all the features, all the code, and all the backend is designed to cater that, not to cater any chat, any messaging application like WhatsApp. They can include that, they can enhance their application to do such tasks as well, but the core design should not be changed. If they will change, then all the bugs, all the features, all the bugs, even the past bugs, has to be retested and has to be removed in a sequential patches before they can launch them again as a messaging app. So that's a very bad practice. So what people do, they launch a new applications again with new architectures, not use the pre-existing and change it. The core, we cannot change the core of the architecture. Now, organization. So it also this architecture designs also organizes the various components modules of a technology. It also defines how these components interact and communicate with each other. This organization part, right, ensures the technology operates smoothly, efficiently, with clear roles and responsibility assigned to different parts. So, if any system has been given a responsibility, it should be set in that architecture, like backend architecture design, that the messages or the roles of the, for example, invoices, this system has the roles and responsibility for the invoices, and it is made clear in the part of the contract. And we get the approval. While getting the approval on the architecture diagram, we find any solution architect will finalize that. Now, next is extensibility. Again, as you as as we already discussed, there should be always a space to enhance it. So it also allows the design, we are like, via design thinking, we design architecture diagram or design in such a way that it also have room for additional enhancements. For example, it also should allow the addition of new modules, components, facilitating the integration of new functionalities or the third party systems. It can also facilitate any third party system or any new system which has come as a challenge, or any replacement of any old legacy systems or any old systems. Let's check the next one. Flexibility. Again, flexibility is like, as you see, I didn't had space, so I included that flexibility in that image itself. So our design should always be very dynamic and flexible, so that any changes which comes to us should not hamper the core of our design, but it should be flexible to accept that change without hampering, and in the most hampering the core design, and in the most efficient way, so that any change come to their way, it should be catered very easily and very efficiently, so that it will be minimum change request for the developers, so that it saves the money, and it will be cost efficient for the client. Now there's so many things how why backends are important. So it backends, like, it's backbone, right? So it's handles the system integration. Backbone is very necessary for performance optimization, because all the calls happens in the back end. They need to make their design such efficient that there should be minimal calls, minimal hops, and then the SLA, right? So client sets an SLA, and there should be the call, the response, and the request should be under SLA, which we can do by performance optimization, which architecture design help us to do. It also, security is a major aspect. So when you talk in terms of financial auditing, financial apps, while designing a backend, we also need to cater the request of this as a person who is seeing things from the point of security. So even our application is fast, but if it's not secure, it's bypassing some certifications or bypassing some routes or encryptions or decryption, then it's it's not a reliable application. It is susceptible to threats, hacks as well, data losses as well. So security is a like very important point of view, same as compliance. So if compliance are basically rules and regulations which one must follow, it can be set by a company, it can be set by any organization, it can also set by rules as a country. So for example, any application if any country is not allowing any process in an application, the application can be deployed at many countries. For example, Instagram is also available in US, it's also available in India, and it's also available in Dubai. Let's take third country. So some features can be allowed in India, but at the same time those features shouldn't be allowed, or not shouldn't be, basically are not allowed in Dubai or US. So we have to design our architecture in such a way that it's also cater the reasons as well. So for example, any calls which are allowed in India should not be allowed in US, in Dubai, if the compliance is there. So that also we have to design and define in our backend architecture. Again, reusability is, if something is already existent, we just need to find a way so that we can reuse it for different or new challenges. For example, this API-led architecture is what API-led architecture is, that it ensures that we have three different APIs in such a way, and three different calls in such a way that experience API is completely isolated and connects with the connect requesting system. Process API works only on the process, and the system API is the one who's most secure and connected to the real systems. So now what we can do is, for example, if you're making a system API for Salesforce, we should design in such a way any challenges, again, if coming in the future regarding Salesforce, we can use that same system API. We can re-enhance that, and you can utilize that, which will also save our vCores. We can also save our RAM, and then it will be cost efficient as well. Now we fault tolerance is also a way where we need to implement in a design, so that any fault, for example, any fault occurs in any of the system, if any of the system is down, we may have to cater in such a way that the error handling is done in an appropriate way, and we send the request. So any fault should be accepted and again processed in a such a way that it doesn't hamper the request, and even fault tolerance in such a way that even if the call fails, We need to retry the call. We need to hit the different server. Those all the things can be designed in a backend architecture as well. Now, why a good design architecture is important for any application? Why it is important? Anyone who wants to share why it is important? A good design is important while designing an architecture diagram or any architecture of backend. Okay, so there are many steps while or hierarchy while this architecture diagrams are there, right? So basically, this architecture designs are not only for the complete application, but also at all the system levels. For example, architecture design will be for the application. Architecture design will be there for all the systems involved in those applications. Now coming down to the systems, this architecture diagrams will be also designed for the system or APIs under that system as well. So for example, let's take Flipkart. Flipkart, we have our architecture design. The whole backend is designed and we have the approval. Then now it comes to MuleSoft, who is making the calls in, for example, in Flipkart. Then MuleSoft will have also architecture design, how MuleSoft will cater all the requests which are designed, which are designated for MuleSoft. Again, after defining that problem, we'll again in the API level also we'll have the architecture design that how that API will work. So it's all distributed in parts. So again, design patterns. First, it's a majority part. So the basically at application level. Again, application type also defines how we have to design. So web application, mobile application, desktop application. If there are all the three application, again there will be three design for all the three in the simultaneously way. So basically, if Flipkart is there in at application type, it will again have three designs, architecture designs at application level, and they can all three be different because it is interacting with different system. So for example, for web application versus mobile application, the architecture design can be different. It will be serving the same purpose. It will be serving the same purpose as in like if you message from web browser, it can be the messaging feature is same as what you do it at mobile application. You message someone, you receive messages from someone, but at the back end both architecture can be very different. Some in the web application calls can be happening in a different way. In mobile application calls can be happening in a different way as well. So this is application type level. Now technology stack level. So for example, this can also be a case when you are doing using web application, the technology stack is different, and when you are using mobile application, the technology stack is different. Even sometimes tables can be different. There can be two different tables from where the data is coming. Only the thing is those tables will be synced, which is like they will be real time sync so that they are catering different requests, but at the end of the time, both front ends or basically the users are getting the same data. But that doesn't mean that the backend table is same or backend DB service is same. Again, architectural patterns at the tip, basically it's a tip. Now it can be multi-layer, service-oriented, microservice, event-driven architecture. So this is the basically at the API level or at the very last process level, how you handle that call. So now that you have to again design the architecture that how it will define your problem and like how it will resolve your problem, and you need to define that. So again, that was one part. The other part is now let's understand as an application how it works. So then a user is generally connected with UI, a presentation logic, which is handled with front end. And after that, when it comes to business, again, this is as a solution architect, they have to decide what is the data access, what are the data utilities, what are the service tools we are going to use, what are the application facade. workflows, component, entities. Again, the local data, how to access the data, how to service, how to sync. The sync part is very important as from MuleSoft point of view, because we have a we MuleSoft, what resolves are is like they can be different systems. I told you, like already told you, that there can be different DBs, different tables sitting in different DB data management system tools as well. So for example, one DB can be sitting a table, for example, a product table can be sitting in Azure. At the same time, other product table sitting can be sitting in an AWS. So the AWS mobile application is using AWS server, and web application using Azure server. Now your task as a MuleSoft is to sync them both at real time or at nightly job. Anything. So if it's a very bulk data, you have to design in such a way that you have to do a bulk insert or bulk upsert at the real time. Then you have to decide what is best approach for you, how the data is coming, what is the update time. So for example, how frequent the data is changing. So all those you have to decide, and then you have to come with an architecture diagram that will make a decision that it will be a nightly job, it will be a weekly job, or it will be a hourly job, even if it will be a real-time call. So any update should, which is a event-driven architecture, any update in one system should be reflected and should be uh, made updated in the second system as well, and MuleSoft can do that. So now we'll have to understand why good design is important, because we need performance is dependent on backend architecture design. Scalability, reliability, security, its modifiability, basically where you can make enhancements, and then again reusability. All those six factors shows how important is architectural diagrams or designs. So basically, backend architecture design is, in the real time scenario, if you say like this, it can be the pillars of the bridge. People are using cars and roads. People are running their cars using the roads. What we see is just the roads. It should be smooth, it should be eye pleasing, it should be safe, it should be like catering all the safety needs of the people. But again, you see that the back end, which is basically pillars who are taking the hit by waves of sea, for example, Bandra Sea Link, is the architecture marvel. We roads can be built anywhere, right? But while building on sea, we need to we need to see the challenges as well. What we can see and relate how the backend has more challenges, and they need to solve the problem. While front end is also challenging, but front end is more focused on customer needs plus customer experience. And backend is totally the logic, the totally the how to make that experience in the best way, right? So again, if even if you have good roads, if you see good, like if while you're traveling to Bandra Sea Link, if you are crossing that and the roads looks very good, but in mid, if the bridge starts shaking and you lose your control, even the road was correct, the road was very nice, you lose control of your vehicle, which will lead to accident. So backend also plays a very important role in any of the application, in any of the architecture marvel, or any of the construction, engineering. So everywhere the backend is like the backbone of a design. Now coming to architecture, so there are different type of architecture. So now some persons are application developers and some persons are application architects. So now we'll distinguish what architecture can be decided by whom. So, for example, a developer can decide their application architecture, basically the inside process at very low level, which is API calls, how the call will happen. That is completely, so basically, an architect will have asked a solution for the calls. For example, I want an endpoint. I want endpoint which cater my request for booking an appointment. So I can give an integration to an developer. Now I can also tell him that what all systems are involved, but at the flow level, he decides how he will call, how he'll use choices, how he'll use scatter gather to make the calls. Again, I can check that design, I can point out the room for improvements, and then again he can re-enhance the design. Again, business architecture also, he can understand what business needs. Again, if I'll say I need that endpoint, it's coming from the business as only, right? So now what I have role in my role, like for example, as an application architect, I'll have to oversee business architecture, oversee application architecture. I need also need to see the system architecture. If my system, whatever the developer is designing, if my system can handle that kind of request or not. So if a developer is designing that it will send me or ping me 4,000 times in a minute, I also need to see, because as a developer he is only responsible for his development as an application. So if he is making an API, he is only responsible for the design and the efficiency of that API. He is not responsible for the other systems which his API is reacting or interacting with. So now, as an application architect or solution architect who is designing for the business at higher role, they have also need to see if the system can handle such loads, if system is efficient, if system allows it, if proper authentication is there. Again, the data architecture, what the system needs. Again, I need to, as an application architect, I need to clarify that to the developer and get the approval by the business. Again, the physical architecture is totally on the business. So for example, I can only ask that I can only tell as an application architect or solution architect that AWS can be one of the best solution for this. Azure can also be there, but let's not use Google Cloud for this application. But for the physical architecture, the person who is paying, basically the business or the client, is, or the company you are working for, the organization is the decider person who will actually invest the money, will decide according to your points, considering your points as well, but the final decision yours. If they still wants to go with Google Cloud, looking at their existing pre-built architecture or other application, we'll have to cater a design in such a way that even with Google Cloud, if it works, and how we can improve it if it is not giving such results. So all these things, and again we'll have to show that to the business partner or the client, and then again get their approval on that. So this is the types of architectures. Now, what are the decision pointers when you're designing any software architecture, right? Any application architecture? What is the uses? What are the infrastructure limits? You have to take decisions on the basis of that. What is the software design? If you're working for a retail marketplace, or if you're working for a airline, all the design can be different. So if you're as a middleware, if you're MuleSoft architect, you have to design, you have to take that decision on the basis of the software design. Now security, you on the basis of the security, how security protocols. So if it's a business application, if it's a marketplace applications, the different systems can share the data. Just a second, I'm getting a call. So in marketplaces, different data, so customer data can be shared to different processes. But at the same time, if you're working with any banking application, any financial audit application, you are not able to do that because of the security concerns as well. So you have to also see what are challenges, right? Security is necessary. That's why it's so from the business and the customer point of view, security is very necessary. Like, it's very important. It's one of the most important thing. But as an application solution architect or solution architect, it's a challenge. because you have to make the process faster, efficient, but at the same time secure. So it's your responsibility. So it's a challenge for you, right? Now you also need to say team skill set, right? I already took this example that if your team is already trained in React, you will pitch for React, right? You won't go for like Angular unless and until it's a mandate from the client, right? So again, stakeholder interests. If you're building an architecture, you'd have to take the approval. If even if it is very efficient, even if it is very best, again, the stakeholder, the person who is paying, is not interested in that. He wants different solution. As a solution architect, it's your responsibility to provide him a new solution and improvise that, even if the systems are not up to the mark. For example, it happens as daily. It is in the real life scenario. This is the most cases. For example, companies are already so deep invested in legacy systems. They don't want to upgrade simultaneously all the systems to the new systems. For example, if someone is already using order management system as a legacy system like IBM DBs, they won't switch. They already have a currently architecture. They have in-house servers, everything. They, if even if you say that you want Cloud Hub is better, for example, to deploy MuleSoft APIs, they will ask to deploy their APIs, the even Mule APIs, to their servers or their runtimes, because they have already invested and they don't want that money which is already invested in that architecture to go with, like those architecture or those uh, like in-house architecture to go as waste. Even it can be, sometimes can be security concerns as well. So they don't want data to be sitting somewhere else if they have the architecture in their house, in-house. So bigger companies, for example, IBM, or like they have, which have very vast uh, technologies, tech stacks, which is there, like already there, they have deeply invested in that. They won't be using, if they use, they will use their own cloud on premises, but they won't be using any other on the go systems like AWS, even if it is cheap, because it is cheaper for the business, the new businesses, but who have already invested in in-house architectures. Then as a solution architect, it's your responsibility to design in such a way that it's efficient as well, even if we are working with a legacy system. Again, needed scalability. You need to see the vision. You have to have a vision that how far the app can be enhanced. For example, if you're making a retail chain application, as an architect, you have to decide what all the future possibilities can be. So right now, if they're not taking any online payment, it's just cash on delivery, you have to check the future scope that the business can so leave and design in such a way that even if in future the business wants its online payment system, it's easily available through the design what you made, so that it is easily enhanceable. Again, all of this has a, right? So again, you also have to see if you have the budget or not. If your client is ready to pay for all the things you are, it can be best, right? So things which are done in 5 seconds can be done with 1 second, in like by changing the systems, by improving the system, by taking the best systems, by taking the best servers. But again, is it required? Is it like required for the client? Is it better for the client? It does it suffices the client's need? So do they need 1 second call? Do they need real time call? Or it can be done as a sync or as a queue based. So all those things, right, you need to take care as well. So again, it's again one of the common example is onion architecture for building software layers. So what any software designer or any application architect, any solution architect will design in such a way that their design or their application is in like in onion shape. So layer by layer, they will start with the core and then they will start expanding, right? So now layer by layer, so for example, the presentation layer, then application layer, the domain, and then the infrastructure, persistence, like all these things, right? It will be layer by layer. That's why it's called onion architecture. It's one of the best architecture which is currently followed in the market. It's very popular as well. So infrastructure now responsible for implementing IO. So that you will set the roles, right? IO operations like input. So it will talk with the like it will communicate with the user. This layer keeps tracks of all the activities of inner layers and import entities from application to domain layers. Again, application is like enabling models to execute business rules, implement application rules. Again, the domain roles and responsibilities contain all the business rules of the software, purely logical. They do not perform any IO operations. So this in this way, the onion architecture is set. Now, let's have as an again coming to MuleSoft, how integration architecture impacts the design of an application. Anyone? So again, as an integration, we are middleware, right? So we decide the data flow. So integration architecture influences the flow of data between different components, systems as well, determining how information is shared and processed and what information is shared, right? So even if you are getting card details, or even if we are getting card details from the backend system, from the DB, it is kept there. We cannot show that card details to the outer presentation layer, basically to the outer user interface layer. Even if it's not an account, if it is not allowed, right? We need to mask it. It's our responsibility that if we are publishing any data to an outer system, for example, if it's an invoice which is going to mail as well as a paper receipt. It's even if we have the card numbers, it's our duty to mask that card numbers, like for example, for the 6 letters or 7 letters. Even if we get CV, we need to remove that CVV part and then print on the invoices or send any request to the target system to print the invoices. Because the target system in such a way, it will accept everything, right? They will have a contact that whatever you send, we don't have a logic in here. We just whatever the data will send, we'll have a template and give invoices to the emails, right? Like email invoices to the customers, right? Then, as a middleware, we have the responsibility. The architecture needs to be designed in such a way. Anytime any mail, any sensitive information is coming, we need to mark. Even we need to remove it or we need to mask it. Again, communication protocols. So sometimes a SOAP system can be interacting with us, and we need to make because MuleSoft has like we make REST APIs are faster, it is more enhanceable. What we'll do, we'll take the SOAP, we'll cater the SOAP request to us. Internally, all the communication will do the through REST. So basically, SOAP to REST, and we'll do all the calls inside. Like design all the architecture in such a way that it's a REST call faster, efficient, enhanceable, and in the end target again. So for example, if it's a get call, a source can also be a target. So after even if it's not like a get call, a target can also be a SOAP request. So a SOAP system. So basically, they also want as in a SOAP envelope body. Now, what you will do, you'll transform the data. You'll have everything collected in inside you as a MuleSoft API, and you'll transform the data and you'll cater that SOAP request. So at the end, it will be SOAP inside MuleSoft its REST, and again you are sending out SOAP information. Okay. So I'm just taking little pause here. So am I audible, Shubham? Just to confirm.
Yes, Robin. Yes, you're good.
Okay, thank you. So again, scalability and performance. So whenever you come around backend architecture, anything, right? Anything related to that designs, architecture diagram, best part or the most important part is performance and the scalability. So basically, right now, if you're using an application, for example, Flipkart, there should also always a room for enhancement, right? So integration architecture as us as like MuleSoft also, integration architecture plays a crucial role in ensuring scalability and optimizing performance. So when data exchange is happening, you need to find the shortest way because our flow decides how we are getting. So we can have async calls as well. If we can call at the same time three systems, like using scatter gather and collect the data from three systems, not have a sequential call to save the time, right? So all these things plays a very crucial role deciding the performance and scalability of any system. Again, the security again, right? So a source system when sends the data and it's inside MuleSoft, it's our role and responsibility to keep the data secure within us as well. So if you are interacting with any system, we need to ensure that if you're sending any data, it's not sensitive data. Even if you're sensitive, it is sensitive. Our internal calls should be well protected and well secured, right? So that anyone from MuleSoft or any middleware integration cannot take the data. So, for example, if WhatsApp, if you're sending some data from WhatsApp, or if you're sending some data from one system, for example, Oracle, to IBM, then you gave, and MuleSoft is sitting between them. So when Oracle gave the data to MuleSoft, it's MuleSoft responsibility to protect that data. So someone from, it should not be MuleSoft API should not be unsecured, right? What I can do if I want to take information from Oracle, if Oracle is very secure and I'm not able to, what I'll do, I'll find the middleware systems or I'll find a target system where I can take the same data. So I will try to attack MuleSoft APIs or I'll try to find loopholes in MuleSoft APIs to take the data from there. So my goal was to take the data from Oracle, and I saw Oracle is interacting with MuleSoft, so I just targeted MuleSoft. So anyone in the point A to point B, anyone can be a target to get the data. So every point from, so it's also a solution architect's responsibility to ensure that point A to point B, which is source to target, every part is secured, right? So again, how it is the integration plays part. Application integration changes as app development evolves. So my use case was in the starting was to search orders, right? Now after 1.5 years the application started giving more features. So now I also need to think like that I will also need to cater future requests as well. So for example, now it's search orders, now they also want to search warranties. Now I need to change or enhance my design in such a way that now I also cater the warranty search part to any application. So again, it can be warehouse upgrade, it can be financial systems which they need now need data. Can be cloud systems they have upgraded to cloud now. You'll have to change enhance architecture in such a way. Now they want analytics, business needs the reports. Now you have to cater that. Now they are going to now it was in store, now they are going to internet web services, now they have to cater that request. Now again, as I told, it can be a challenge to work with legacy systems as they are slow and they are very limited and very rigid, not like the current systems or the new systems which like are very not very rigid and have more ways to interact with and gives you more efficient way and are more secure as well as are more efficient in ways of communicating, right? And there are even more ways of communicating, right? So now third party applications are also there. So some third party vendors are there. You need to be designing the way such that they don't get any sensitive data. Again, e-commerce websites. So for example, you have some, you are using Amazon at the same time, or Flipkart at the same time, you want phone pay to interact with you, which is a while making an order, completing an order, you are giving a feature that you can do a UPI payment, and now you're sending your customer to phone pay to make the payment and then bringing back that customer as well at the same time. So all these things you need to cater as an integration architect. Again, the second example is like, again, it can be connecting with CRM, third parties. It's same thing in a different way. So it can be, so in the last part, it was revolving around any ERP, basically enterprise application integration. Now it is connected, everything is connected to application integration. So everything integration is handled. Now, so this was a two application. Yeah, let's see. Yeah. Now let's go to check what is complex architecture versus simple architecture. So what complex architecture is? If many systems are involved. So at the application level, right? For example, as a Flipkart level, if you see what all process it's doing and everything, that application design will be very complex. A very senior architect will be understanding that how the process, because he has to see everything, right? Inside system, outside system, internal system, everything he has to design. So will have to he will make an architecture in such a way that will be very complex to understand. It will be very complex, right? Again, what he will do after designing that complex architecture design, because he will have a very deep knowledge in that. He will have design every calls, everything, every SLA, everything, and he will get the approval. And then for he will distribute that to his lower tech architects or to his colleagues in such a way that is simple to understand. So right now it is, if you see, it's an diagram which is not very complex but still bit complex. So he's saying that it's going to architecture synthesis, then SDL synthesis, coming back, hardware compiler, the application sitting here, retargetable compiler, assembly code, SDL cost. So, but now if he sends this to MuleSoft, MuleSoft will have to know that what are their roles and responsibility and what part. So, for example, if MuleSoft is playing this part, they will need only details, deep details to this part. They won't care about retargeter system and assembly code connection. If it is Dell Boomi is doing that or any other direct calls are happening, right? Through Python or something. So if it's a Java code, MuleSoft doesn't need that information. It just will be over information, because over information is also a thing, and it will just slow the process. So now what an application solution architect what will he will do? He will break these designs into simple designs. So now he will give this to us, right? Now what we'll know that MuleSoft part is this. Again, he will distribute that design. So now he will make, for the business, he will make this design that this is more simple to understand, and the client will understand what will happen. For example, how he will be protected from firewall, the sensor will react, everything, right? So enterprise network he will show. Maybe inside it is very deep architecture and very detailed architecture which is happening, but if for the business this is well enough, and they will understand the process, right? They don't need every details, every call, though they will have that data, but they don't. So for example, a manager, or for example a business person like CFO, who is looking, or CSO, chief security officer, he doesn't need that information, but he will need this information to understand how the process is happening. Again, so just a second, how he will give us MuleSoft. So let's go back. So he's saying MuleSoft, he will give this design for MuleSoft API. So for example, here it is a sync process, which doesn't need any customer or user interaction. He will give this design. So this design says that there is a sync process API. They will retrieve the data from product table sitting in any DB. They will take that relay data, which is like unprocessed data. Now they will bulk insert in the system API, right? They will not bulk insert in the system API. They need to insert in the service. So for example, if there is some service or system, they need to insert the data in the target system. Now what they will do, they will make process the relay data. So they will process the raw data. Again, they will make it a relay data. So basically, which is a JSON format. For example, this needs MNT files, CSV files. So, but JSONs are more easy to work with in the REST APIs, and if they're more efficient, so what we'll do, he will give this. So he will say that retrieve the records, do a bulk insert using system API to the system. So, for example, if this is Oracle system, this is your MuleSoft, you have to do this. Now, as a developer or as an internal tech lead, he will say that use this. For example, name this API XYZ process API, name this API as a system. For example, this is Oracle. So Oracle system API use a batch job, convert into a relay data or in a process data into a JSON format, send this to system API. Now system API will be connecting to service, the direct service or the target system, and then he will send that service data. Basically, all the transformation needed in the system APIs will be done related to the system will be done in system API and will be directly now. So for example, a header needs to be attached, right? Which is only related to system, which is not related to any process. What we'll do, we'll add a header in the system API to the already processed data and then send a single file. If they want a single file, we'll send a single file, single MNT file to the service system or the target system. So this is at API level or process level for the MuleSoft. But just a second, this should have been up. Yeah. But at at senior architect level, this was his solution. We got that, and business got this, right? So this should also, I think, somehow slide got, yeah. So again, so this was the process, right? We missed one topic due to slide mismatch. Conversions of trend may also simplify application integration, right? How simplify in the sense means, for example, right now we are all into basically uh, trend into like play games, right? Mini games in the application as well. So for example, even if it's a marketplace, what Amazon will do, he will see the trend that all the marketplace applications are giving games also, some features of games or some features of video. They will try. So if you noticed, Flipkart for a limited period of time include Flipkart video as well in their same application, right? So now they had also need to include that video, but they saw that for running 2 or 3 months in production or 4 months to users were not clicking, the calls were not happening. So for example, they have 1 million users, and even not 1,000 or 2,000, even not 1% of that user base was not using that feature. So that feature is no longer needed in an architecture diagram. There's no longer needed in that architecture design. Now what the architect will do, he will take that part out of that design, right? Now he can, that part is throwable. They will not throw that code, but they will comment it out. For example, they will keep that in the, for example, backup repo, but they won't be, that code won't be in production anymore. So again, that architecture which was more complex, that because it also had a video part, now that part is gone, right? So it will be more simple. So as your product or application grows, right, the initial part will be very complex, but at the end of the line, it will be very simple. And the architect can give you a very simple diagram. So, for example, any person, even not non-tech person, looking at the diagram can know what is the process of that application. So, for example, phone driven trend, PC driven trend. So there were trend where there were PC solutions were increasing portability, they were making PC application and all. Phone came into existence. Now they throw, not thrown, but disvalued the code. Now they have promoted, now they have been started working on the phone driven trend. For example, Android applications. Now they were not using web service application. Now they were more keen to this revolution was done in like 2000s, 2010. So after launch of iPhone, Android phones. So all these changes were done. So pre-existing designs were enhanced to check phone driven. Now, so earlier it was like 80% it was PC driven application design and only 20% was phone driven. In 10 years, now it's just phone driven application and only 20, now 80% is just phone driven driven application design and only 20% is left with the PC driven. So it's convergence as well as emergence. So new business means like new designs, and you have to enhance design, because again, for example, eBay, right? So eBay is a very old website, right? So they were more based on websites, right? Facebook were more based on websites. It was website applications, right? It's web applications. Now the users on web applications are very low, and now they are mobile applications. So mobile based applications. So now no one use uh, Facebook on web service like as from Chrome. They use it, but the if you see the user base, the mobile application users are more than compared to any web application users of Facebook. So they are now more focused on mobile based architecture. So again, now new change. If you see now people were keen to IoT. Now what they did, so basically Internet of Things. Now they try to connect with internet. Now, so now what they did, now they wanted single click and they wanted without change. So from their mobile they can interact with their like with their light, basically light bulb. Now as the technology growth happened, now they don't want even from the mobile to interact with from your ping or basically your interaction with user to interact with mobile phone light bulb. They want artificial intelligence, right? Intelligence basically, that system should know your behavior when you're coming, when you're going, and according to that he should turn on the light bulb, he should turn the temperature of the AC, learning from your behavior. And it's a continuous learning. So if you, even if you change it, again adapt with your behavior. So again, this is the conversion of blockchain and AI towards IoT. So now decentralized network became, artificial intelligence came, digital signatures were used, because digital signatures are like which process it is, how, where it is coming from. So these were like from the security point of view as well. Validation, immutable ledger, like basically anything if once done is final, you cannot make any changes in that. So smart contracts, basically the smart contracts are basically it's on the go contracts. So you don't have to you need to see the system requirements, you have to check if you are feasible and just say yes at that time. You don't need to go with all the process. So again, digital ledger, where like every person on earth, like any person can see that, accessible to everyone. Again, in the it is secure in such a way, even if it is accessible to you, you cannot change that. So this is was all a part of revolution, and how architecture designs played crucial role in growth of digital transformation of us. So basically now we'll come to a small demo in the MuleSoft side. So again, I already explained this all, but again we'll see in terms of API development. So this is a card service, right? So we'll start the process. We'll have a transaction ID. We'll say that services started. Now we'll log the request for better visibility and better debugging in the debug mode. Then we'll set the variable, save the that original in case of reprocessing if it is required. So for example, just to give the overview of this request, the card services is nothing. Basically, if you're going to Flipkart, you're adding something to the cart, it should stay in the cart until and you make a buy. It should be saved. There's option to save in the cart. Even it can be dropped if you go back to go back from your that application. There's again, it's your choice how you design it. So now this is cart service. Now what we get a request that user has, now we got to know that user had added something to the cart. Now what we'll do, we'll transform the JSON payload. We'll now will if the voucher is attached to that cart, now what we'll do, we'll send the service cloud. So we'll send service cloud the coupons and everything, and then call SFSC system with the request payload and check if that coupon is valid or not. If it is valid, we'll give the green go to the cart, and then the business will, other systems will process the basically discount the amount from the card. For example, if it's like $1,000 and we give a $10 discount, it will be $990. But if we rejected that, okay, this system is not, so you try that, we all have been to that place where we tried any voucher, any first 50 or any voucher, and it says this voucher is invalid or this voucher has expired if you use any old voucher. So then that validation part we do from the MuleSoft, It's our responsibility in this scenario where we got the design, and then we give the final response, and this we make cart. Now in the SF, basically service cloud call, we take the security token of the service cloud and then send it to again send it to commerce cloud to check the validation. So we made three calls: token call, service cloud call, and commerce cloud call, just to check everything is in the place. And then we respond target system, like the source system. For example, if it's an system, for example, Flipkart, then we said, yes, you are good to go. It's a green call from us. We take the responsibility from the, and we interacted with different systems to check if the coupon was valid, and when we send the positive response. So this can be one of the scenario, right? So now this was a POC of mine. Now let's make another POC right now only. So let's make inventory adjustment. Okay. What? So cart. So after this process, right? This, let me rename it to cart. Sorry, carting process. So if this carting process is completed, the target system, now what we need to do the adjustment of the inventory, right? So it's not necessary that it will be a real time call. When this carting process is completed, a request will be sent to our like a Java queue or our internal queue, that transaction details, they will send the transaction details, they will publish in a queue, and all other systems can be interacting to that queue and taking the data from there. So we will be also sitting in that queue looking for any update. We'll have a subscriber. I think MQ is subscriber, or let's have this subscriber, Salesforce subscriber only. So what we are doing is we are listening to the topic. So what they are the source target has done, they have completed a transaction. Now transaction is completed. They will a send that transaction as a sale, that a successful sale to a topic, and all other systems will be sitting in that topic, basically listening to that, and any update in that topic, they will trigger the flow. So here also we'll do that same thing. Any change in that topic will have a trigger, and now we'll take that data, save it for the reprocessing, and now that cart has been done, so that item has been sold. So this is inventory adjustment. So any, let's take, I'm a seller of Flipkart. Okay, so I had one Adidas shoe. Now I successfully sold that, right? Now I'll have to make the inventory adjustment, so that in the back end also they know that this item has been sold, they need to restock. In the front end also they will know that now they need to remove that. So that is another system who's showing that data, that now how much is available. You see that, right? Size 30 is not available, size 28 is not available, size 20, 30 is 34 is available, like two pieces, three pieces. So now that data we'll have to adjust. So now we'll take that data, we'll save it even if it fails, so just to make fault tolerant. Anything happens, we'll just make a reprocessing strategy and reprocess it afterwards if the system is down for a few seconds. So we'll transform the data, we'll save it as like a original payload, right? I'm just writing to explain you that we're saving it as an original payload in a variable. We are then again transforming it, because the target system may, so for example, their inventory system, for example, order management system. It can be Manhattan, it can be Snowflake, it can be a table, right? So according to them, we'll transform the data. Okay, let me write it here only. Maybe more original payload, just to say what was the original payload in case of reprocessing. That what was with what came to us. Then transform accordingly. So transform according to system. Now it's a designing part. We'll check if it's a sale, sometimes it can be also a return, and then we'll have to increase the inventory. So we'll check if sale, and we can also at default, again you have to check if defaults, it can be, if there can be multiple scenarios, sale, return, exchange. So I'll say that default is return. If sale flag is not coming, we'll say that it's a return only. There are only two process. There's no exchange available. So sale and return. So for sale, we'll have a transformation, right? Now, what we'll do, not transformation. For example, okay, let's not do transformation here. Let's do this transformation according to system, and let's do transformation here. So what will happen, we'll do this according to system, but we'll do -1, right? And now this is a return, again transformation according to system. Now we'll do +1, right? So now we'll make a request. So again it depends, right? It can be two different systems, but this is an order management system, target system, OMS system, right? So now we are adding requesting to target management system. Again, we can have another flow. Again, it depends. Now this part, right? Now this part was that part of the process, right? This needs to be done. Even this can be removed, right? This can be, for now, let's remove it. So this is our use case, that add one, like +1 return, then +1 sale, then add one, and then the request. Now this was what your tech lead or your tech solution architect asked you to do, that ask you to make the solution. Now what you will do, after getting this requirement, you will enhance it, you will make it fault tolerant. This is to the developer, like, okay, this happens, you have to use error handling. If something happens, is sent to error queue, or if it's continuously happening, we have send it to dead letter queue. If the data issue, which a transaction came, which was not in a contract way, was not in a what was already declared as a wrong format, so right, then you will do that, right? So if there is not, you will, what you need to do again, you will make it as a common. If some happening again and again, you will take it here. All these design changes, right, it's up to the developer, right? And up to the developer, and also on the basis of what are the best practices of the market, best practices of the organization, and what is conveyed from the tech architect or the tech lead, right? So now you'll do, again you will do a choice. You made the transformation, again you will check. For example, you want to send this here, you want to send, sorry, not again choice, let's have one scatter gather. Now at the same time, what I want to update three system. I don't want to wait, because there's a, so, and we'll also use try, that if it fails in one, it should fail in, so you have to add the try scope. It's not added to this. Let me go to all. Now what do we need to do? Now we need to make three requests, right? So request one, request two, request three. And what we'll do, we'll make this request here. What? And each request will save it in variables also. It can be, so scatter gather will also give you a payload here, which is a combined array of all the three requests, but it still will save as we want different values. So we'll have this value. So this can be marketing cloud, commerce cloud. So They also want an service cloud. So what they want, while you're doing the inventory adjustment, also send this data, right, to Commerce Cloud, and also do an invoice, invoicing a system where you need to send the invoices to also, right? So what we'll do, before making this call, we'll make a scatter gather again. So see how the process, now it's getting complex, right? Now, like the time we are trying to add everything, right? The design will maybe more complicated. But again, after the, okay, it's not coming here. Yeah. So now what we did one scatter, we get all the data, like we got all the data. Now we are making this sale, and our original use case, they wanted more to add. So what we'll do, we'll have another here, and again request, it's like OMS system only, but it is their different endpoint, right? So again, it's when I say OMS system, it's OMS system API, right? Now what I'll do, I'll make a final call here, not here. Let's make it inside choice. Okay, it came. Okay. So basically the point was to first scatter gather, make two different take choices, make calls here. I wanted to make us like inside this only, but it's not somehow going. Let's see, it went. Yeah, it went. So now we have two processes, three processes basically. It should be here. It became one more call. Fine, it's fine. So basically, we divided the process, we divided the events, then we made the choices, we made this call, we made this OMS call. This is also OMS call, but to different endpoint. Now this is OMS. This is invoice call, and this is like a system. Both are going to OMS system API only, and we are making different endpoints. For one is for getting the request for invoices, and other is getting the request for inventory adjustment. Now this is again before inventory adjustment. In the payload, we only got customer, not customer name, product number. Which was sold. Now, this product number is not known to MS. Then we'll get Marketing Cloud or Commerce Cloud, and we'll see what are the data of this product number, because this OMS system will need more all the things. So now we'll get to Commerce Cloud. We'll check that what the requirements were, and then they will come back. So this, let me make it big. So this is a simple process, and see it became complex. Now we'll have to make comments or subflows to make it more visible or approachable, so that it works. So this is how you design backend, and this is how you design architecture of any application, any process, or any API. It's up to you. Basically, what you are, it's your challenge. Let's come back to the PPT and let's have some Q&A. So anyone, any doubt, anywhere in the session or anything you want to share?
Anyone any questions? Feel free to enable your mic, and or any feedback you would like to share. If not, then we can wrap it up.
So
Yeah. So if you want to speak at our meetup and or any other, so you can reach out to the meetup leaders. Okay. And suggest a topic, so we will help you with that as well. Yeah. So share your feedback, and that's all, I think.
thank you everyone. Thank you for
Thank
your
you,
time.
everyone. We are okay then. We are good. Like,
Thanks all. Thanks for your time. Thanks, Shubham.
thank you.